today's going to be fun. We'll see if we succeed or fail. So just last week, I got my brand new, can you see it? M1 13-inch MacBook Pro. I have been so excited about getting this. My prior machine was 3 years old, and I've really been looking forward to upgrading and using the new speed of the M1. However, as a developer, there's a major drawback right now. It's currently mid-December 2020, and that is that Docker for Mac is not yet compatible with the M1 chip. So I've been racking my brain about what to do about this because most of my development happens in Docker. So one idea I had is to use a Raspberry Pi to run Docker on and do my development that way via my Mac, or I guess on my Mac via the Raspberry Pi. And there's something new I've learned about recently, which is VSCode's Remote Development extension, which allows you to essentially run VS Code on a client like your MacBook, but actually everything is happening on a computer elsewhere like a Raspberry Pi. So in this video, we are going to put together this Raspberry Pi. I literally got it delivered today. We're going to put it together. We're going to install Ubuntu on it, Ubuntu server. We're going to get Docker running on it, and hopefully get everything tied up with VS Code Remote Development. This will be my first time running through this all the way through, and so we'll see how it goes. So let's start with the Raspberry Pi itself. So here's the Raspberry Pi. This is a Raspberry Pi 4, so it's the latest version, and it's an 8 gigabyte of RAM, and then it came with this 32 gig micro SD card. I bought the CanaKit version, so it came with this cool case, and I have a fan and some heat sinks, and so we're gonna put this together. The only thing, I really haven't done anything yet. The only thing I've done so far is I have pulled out the power cable and an Ethernet cable to use as we go. So let's start putting this together. I should say I've had a few Raspberry Pis before, and prior to this video over the weekend, I tried to use one of my older Raspberry Pis to get this kind of setup going, but I ran into an issue where the older Raspberry Pis aren't compatible with some of the packages that I'm trying to use. And it can't run the 64-bit version of Ubuntu either, so had to upgrade here. So let's place this in here, and the guide has, the guide that came with this says where to put these heat sinks. So we're gonna go ahead and place these heat sinks here. So let's do that. So this is the biggest heatsink, I assume. Let's see, what is this? Okay, so this is going on the CPU. Here we go. So we'll place this on the CPU. Great. And then the next one goes on the RAM. This is the next biggest one. So we'll peel back the adhesive cover on it. This one doesn't want to come off as easily. Come on. There we go. Okay, so this goes on the RAM. That's this part. By the way, I'm just following the guide here. I don't have this memorized. I don't even think I had heat sinks on my old one. Okay, there's that. And then the third one, where does that go? The third one goes on the USB 3.0 controller. So I'm going to peel this adhesive back. Okay. And that one goes right here. All right, there we go. So we have this bottom base of the case here, and we just put on our 1, 2, 3 heat sinks on our various places as demonstrated by the guide. And now it also came with this fan. Now my last Raspberry Pi, that might have had a heat sink, but it definitely didn't have a fan. So let's see what to do about that. This is the top part of the case, and it has a place to put the fan here, but you have to plug it in somewhere. So let's see what the guide says about that. So it says, if you intend to use a Raspberry Pi for high performance applications, which we might be running a Docker server, then you might want to use the fan. Connect the red and black wires to the GPIO header pins 4 and 6 as indicated below. So the Raspberry Pi has this cool GPIO interface where you can buy lots of different Raspberry Pi accessories to plug into here. And I guess a few of these are power. And in the guide, it's showing us we need to hook the black and red wires up to there. So we will do that. Now, which one is which here? Let's see. Okay, we're going to assume that we're going to assume that based upon the letters, that this is the bottom. So that means the red goes in, let me do this over here. The red goes in the top left, but one over. So plug the red one in here, and then the black one goes right next to it. So we'll plug that in here. So that should power our fan. Let's see. So let's put the fan in the case here now. Which way does the fan blow? That's a good question. I don't know. Okay, let's put it, okay. I think the fan must blow that way because the wires come out the bottom here. So we'll put it in like this. Okay, so we've just kind of lightly placed the fan there. And now, can I do this? Okay, great. Now we'll put on the outer edge case. Great, that fits on. And now we will try to place the top part. Okay, awesome. See if that fits on. Great, there we go. Okay, so it looks like it's put together, but we'll see if this works. So what we have now is I have the micro SD card, and it comes with, this CanaKit version comes with, I think, Noobs on it, which is kind of an easy to get started interface, but in today's video, we're going to actually use this Raspberry Pi as a headless device. I'm not going to plug it into HDMI or anything like that. So we're going to access everything remotely, and I'm going to install this as if this SD card were just blank. We're going to completely write over this. So let me place this to the side for now. Place this guide to the side. And I'm going to switch over to my computer so that we can prepare this SD card here. So let me do that. 1 second. Let me get switched over here. Okay. Back on the computer. So one really awesome utility that the Raspberry Pi group has come up with is this Raspberry Pi Imager. And you can download this from the Raspberry Pi website. And what it lets you do is choose an operating system that you want to load onto an SD card. So I'm going to load on Ubuntu Server 64-bit edition because I had tried this on my other Raspberry Pi, and I could only use the 32-bit version because I had a Raspberry Pi 2 before, and so I'm going to use the 64-bit version this time and try that out on this Raspberry Pi 4. So I'm going to select Ubuntu Server, 64-bit server, ARM64. That sounds good. I won't use LTS. I'll just go right here. So I've selected that, and now what I'm going to do is I have this SD reader. This happens to be an Anchor one. And I'm just going to plug my micro SD card in there and plug it into my computer. So let's plug that in. It should recognize it. Choose an SD card. Here it is here. I'm just going to double check my server selection. So 64-bit server, Ubuntu server, ARM64. Great. So we'll hit right. Yes, I want to continue. I'll type in my password here. Cut over to myself. Okay, so it is writing to the card. And now we'll just wait a bit. So I have the Raspberry Pi here, and let me switch over again to the camera. So I have a power, don't know if you can see it. I have power and Ethernet ready to go. You can set up Wi-Fi on this. I'm not going to run through that today, but there are plenty of guides online to do that. So I'm just going to use Ethernet and USB-C power with this because this is powered from USB-C, and get going. So we're about halfway done writing, and then we'll boot it up to see if it works. Let me check the stream here while we're waiting. Okay, looking good. 2/3 the way done. Great. So what I'm going to do is I'm going to when this is done, I'm going to take out the SD card, plug it in here, plug it into power and Ethernet. And I have, on another computer to the side here, I have my internet router interface pulled up. That way it's just a really easy way to find out what the IP address of this thing is. There are a few different command line tools that you can use to find out what your DHCP IP address that gets assigned to this box will be. I'm not very proficient in those. I don't know them offhand, so I'm just going to use my router's interface and look at the devices that way. So it looks like it's written to the card. It's verifying now. So we should be able to go here pretty shortly. Now, one cool thing that I've found before, let me see if I can, let's see. one cool thing that I'm going to get running on this device is instead of having an IP address to memorize all the time, there's this really cool thing that I found called Avahi, and it allows you to have a friendly host name that you can use on your local network. So for instance, I think I'll make this one devserver.local. And that way I can refer to everything within my local network as devserver.local. And that'll be much easier than having to memorize this IP address. So let's actually take a look at that. And let's look at this. So here it is here. I was looking for the official instructions. I'm just gonna hide that for now. Okay, awesome. So the SD card has been written. So I'm gonna hit continue. It's already been ejected for me, it looks like here. So I'm just gonna unplug it. And I'm now going to take that out and plug it here into the back of the Raspberry Pi. So we will stick this in. See which way it goes. Not that way. That doesn't quite seem right either. Although I can't tell. My other one kind of had a bounce to it, so I can't tell if this is right or not. Let's see what the other one is. I have my old Raspberry Pi here. Okay, it had the color up. Okay, we'll try this. So now I'm going to plug in power. I hear the fan, and I'm going to plug in Ethernet. And I see lights, so we have power. That's a start. Okay, well, let me pull up my router page. I'm gonna do that on a different computer. I don't wanna show my router live here. So let me clear and rescan here. Looking for a device. I think I see the one here. Oh gosh, there's a lot of devices. Oh goodness. Okay, I'm looking for my device here. And let's pull up iTerm and see if we can SSH into these. So I'm going to quit this Raspberry Pi imager. So what I should be able to do is SSH into Ubuntu now if this has properly booted up. And this way we can see if this is working. So I believe the default username and password is Ubuntu and Ubuntu. So we will try this out. I have like maybe 1 or 2 devices on my router page. I think this might be. So let's see. Let's see which one this is. Okay, let's do SSH. Let me increase my font size here. SSH Ubuntu at 192.168.1.88. Okay, that's not it. Let me try. This one might be it. Let me try 104. That's interesting. Okay. Well, okay, so this could be a couple of things going wrong here. Either my Raspberry Pi isn't booting, or I don't have the right IP addresses here. It definitely should have booted up fast enough for us to be able to see it now. So I think what I'm going to do is real fast, just to prove that this is booting or not, I am going to plug in the HDMI cable just to see if we can see a screen and see if anything comes up. So hang tight with me just a little bit. I'm going to go behind the camera here. Oh, actually I can't. The cable I need is plugged into my camera, so I'm not going to do that. Let me try. Let's see, that one timed out. Let me look at my list again here just to make sure. Okay, 88. Oh, here it is. I found it. Okay. Whew, I'm using the wrong IP address. 111. There we go. Okay. Okay, I just had missed this in the router list that I was looking at. So maybe it would have been better to use the command line utilities to find this anyway. Okay, so I'm using the username Ubuntu, and I'm pretty sure the default password is Ubuntu. Great. Okay, we're in. So that means the Raspberry Pi's working. Everything is hooked up appropriately. We have power, we have Ethernet. The light came on, it's connected to the network by DHCP. So this might be the point where you could configure Wi-Fi if you wanted, so that you could unplug the Ethernet cable and put this anywhere. I'm not going to do that in this video, but there are tons of great guides online for how to do that. So we're just going to use Ethernet for now. It wants me to change the password. So it says current password. So the current password is Ubuntu. I'll type in a new password. And there we go. Awesome. So we so far have a running Raspberry Pi 4. That is great. I'm going to check the disk space because I'm interested in that. So we have... Interesting. Okay. All right, so the first thing we're going to do is we're going to update and upgrade the system just to make sure that we're running the latest of the currently installed packages. So I'll do a sudo apt update and a sudo apt upgrade. Oh, somehow I got disconnected. I'm back on my local host. I don't know how that happened. Okay. Oh, that makes more sense as to why the disk space wasn't making sense to me. Maybe it disconnected me and I didn't notice after we changed passwords. That's probably what happened. Okay, now we're back here. Now let me check the disk space. Okay, this makes a lot more sense to me. So we have we have available 26 gigs on our main volume. Great. Now let me do a sudo apt update and sudo apt upgrade to make sure all the packages are up to date. So right after that, I do want to get this Avahi thing figured out. I'm gonna go to some old notes that I had for setting up a prior Raspberry Pi so I can see exactly which package I installed. Okay, great. Okay, yes, I will use more disk space. I could have put a -y in those commands to skip that question. I'm glad I just had the wrong IP address earlier. Okay, so this is downloading and installing, upgrading all of the existing packages we have on here. The next step will be, like I said, we're going to install Avahi, the Avahi daemon, so that I can reference this by a nice friendly DNS name on my local network instead of an IP address. And then we'll move on to installing Docker. While that's going, let's pull up the Docker instructions. Let's see, I think I just want... This is not what I did the other day. I honestly don't know if Docker, I guess Docker Engine is the, okay, I guess Docker Engine is the main package. I don't know that I even knew that. Let's see, so we'll just follow the official instructions here. Okay, we are still updating packages in the background here. We'll put that to the side. The fan is a little louder than I was anticipating. I could try not using the fan and seeing if it overheats or not, but it has a little bit of a hum to it here. Okay, almost done with the updates, and then we'll move on. I did install Docker the other day on my Raspberry Pi 2 that I have here, and now that I don't really remember how I did that, because I did not go through these steps here. I would have definitely remembered that. So I'm not confident that this is what I'm trying to do here. But it is pretty clear. We will move on to, after installing Docker, also installing Docker Compose. Okay, well, we will follow the official instructions for Ubuntu here. That sounds like a good idea. Almost done. Do. We might have to reboot the Raspberry Pi after this, so we'll see. Finishing up, maybe? Okay, there we go. Looks great. Okay, so let us, let's see. So according to the official instructions here, it wants us to remove old versions of Docker in case they're installed. So I will go ahead and do this. I doubt that any of these are installed, but we'll see. Okay, sounds good. And now we will set up the repository. So we have already run update, so that's fine. So now we'll want to run these other items. And then we'll add Docker's official GPG key. Yeah, I definitely didn't do this the other day. I don't know how I installed Docker the other day. So we will add the key. This is the official website. Warning, apt key is deprecated. Okay, that's fine. Verify that you have a key with the fingerprint. Okay. We do have this key. Okay, that looks good. Okay, we are running on ARM64 here. So let's do this one. Okay. Now okay, so that was all setting up the repository that we needed. So now we're going to actually install Docker Engine itself. It wants us to run update again. Perhaps that's because we have a new repository. Let's see. Okay, that's done. So now we'll install Docker Container Engine, CLI, and Containered. To be honest, I haven't used Containered before. I'm not sure what that is. I'll have to figure that out later. So what we're doing here is I'm getting Docker installed, and then I'm going to get Docker Compose installed, because those will be prerequisites for being able to run my dev setup on this Raspberry Pi. Once this is all set up, we'll kind of switch gears and open up VS Code and get remote development set up here with VS Code. Oh, you know what I didn't do? I didn't set up the Avahi friendly DNS name. We'll do that too. Okay, so those all installed. Let's see, to install a specific version, I don't really care about a specific version. Okay, that doesn't matter as much to me. Okay, so now we'll verify that it's running. So we will sudo docker run hello world. We're pulling, that's a good sign. Hello from Docker. This message shows that your installation appears to be working correctly. Excellent. Okay, there we go. So we have Docker. Let's move on to now Docker Compose. So I will just pull up once again the official instructions here. And Docker Compose is, I believe, written in Python. So a lot of these instructions will have to do with making sure your Python setup is good. And they have a shell script that you can run. And that's what I'm going to do here to make things easy. Let's see, for Alpine, blah, 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 blah. Okay, so we will try Docker Compose. Permission denied, that's expected. Here is a command you can run to add the execute permission to what we just downloaded. I guess that actually wasn't a shell script. This was actually downloading Docker Compose itself. So let's check the version. Command not found. Fails, check a symbolic link. Okay, we might have to do that too. Let's try Docker Compose version again. Command not found. Okay. Let's see. Let's list out what's in our user local bin. We do have Docker Compose. It looks like a tiny file. I have a hunch that may be a whole lot of nothing. Not found. Okay. So what we did earlier was we downloaded a file from GitHub, and that was a big 404. So I'm trying to run this file, and it's really just a text file that says not found. So I'm going to delete what we downloaded here. And I think what we'll have to do is now go over to alternative install options. And that's where we're actually going to use Python and pip to install Docker Compose. So I'm going to, I probably don't have all of the Python dependencies installed since this is a brand new version. So I'm going to make sure that I have everything I need. So Compose can be installed from PyPy using pip. See the virtual env tutorial to get started. Okay, so let's see if we have Python. I kind of doubt that, but we'll see. We don't. Okay, so we can install Python or Python 3. Python is Python 3, command Python, no, how did you mean? Now I know there's this whole big confusion between Python 2 and Python 3. And I don't do this enough to know if I do an apt install Python exactly which one I'm going to get. But we're gonna try that. I know you can do apt install Python 3. Okay, so this says Python is Python 2. That's definitely not what we want. So I'm gonna Control C out of this, and we're going to sudo apt install Python 3 and also pip 3. That is apparently not it. Okay, let's get Python going. Let's see, Python 3, set to manually installed. Okay, so we have Python. Do we have pip 3? Okay, there we go. This is what we need. Okay, so pip is the package manager for Python. And that is how we'll install Docker Compose here. In case you haven't noticed, I am no Linux expert. So there'll be lots of Googling in this video. Okay, so getting closer. So if you are just tuning in now, what we have done is we have set up this Raspberry Pi 4 here. This is as far as I can pull it over. This is a Raspberry Pi 4 that I just got today. It's 8 gigs of RAM, and what I'm trying to do is get Docker and Docker Compose installed on this so that I can continue development now that I have this nice shiny new Mac M1 MacBook Pro where Docker for Mac is still not yet compatible with it. So my goal is to get this Raspberry Pi going for my Docker development and use VSCode, the VSCode Remote Development extension to be able to develop remotely on my Mac, but using the Raspberry Pi. Okay, so pip is installed. Let's see. They want me to set up a virtual environment. That sounds nice, but I'm not sure that I'm going to go through that. Okay, so pip is now, we have pip running, yay. Pip is now installing Docker Compose. Once this is done, I still don't want to forget to install the Avahi daemon and get that going, and then we'll switch over to VS Code and see if we can get the VS Code server set up on here as well. Another thing I looked into since I got this M1 is, could I use GitHub code spaces to do development while I'm waiting on Docker for Mac to be compatible with the M1? Because I was granted access to GitHub code spaces, but as far as I know, you can't have multiple GitHub repos in a single code space, at least not right now. And the main project that I'm always working on, we use multiple repos together. And so that's kind of why I need something a bit more customizable. Plus this Raspberry Pi will be here local on my local network, so it'll be super fast. And it's fun. What are you doing on a Sunday? Oh, I'm watching someone on YouTube install packages live. Building. While we're waiting on this to build, I will plug. So this kit that I bought this kit on Amazon, and this is the, try not to show my address here. This is the CanaKit, and it's super handy. It comes with a case, a power supply, the fans, the heat sinks, comes with an SD card. It even comes with a micro SD card reader in case you don't have one of those. I happen to already have one. And it even comes with this is kind of interesting. It comes with this push button. I guess this is something you can use the Raspberry Pi to program, some sort of on-off switch. I'm not sure. Oh, maybe this is for power on and off. Maybe. But this kit is pretty cool, and it comes with everything you need. I already have a couple of older Raspberry Pis, and I was just going to buy the board alone and use the old cases. But you can't do that because the old Raspberry Pis have a real HDMI port on them, but the new Raspberry Pis use micro HDMI, and they actually have two outputs. So the case is the same size, but the port layout is different. So let's see how our build is going. Still building packages here. My metric of success today will be, can I use VS Code Remote Development to pull in a repo that I've already started, kind of as a very base of a future project I want to work on. And can I get Docker booted up on that and loading the web interface at all? This very basic setup that I've started in this repo is an Apollo server, so I'm hoping to see if I can load Apollo Playground, and if that works, then this is a success. That would be awesome. Okay, so this has theoretically installed Docker Compose. Let's see. There we go. Okay, awesome. So we have Docker installed, we have Docker Compose installed. Now, one side tour is we're going to install the Avahi daemon. So I'm going to do a sudo apt install Avahi daemon. And what this will do is this will use whatever host name you have set up in etc hostname, and that will be, whatever that name is, .local, will be your DNS name that you can use on your local network. I'm interested to see if this comes with a host name. It comes with Ubuntu, so you could do ubuntu.local. I'm going to change this. So I'm going to change this. I might have to sudo that. I'm not sure. Oh. I haven't gotten my meta keys to work on here yet. Okay, so this is going to be, I'm going to change this to dev server is going to be my name. Okay, so now my host name is dev server. So what I should be able to do is, with the Avahi daemon running, is ping this as devserver.local on my network, on my local network. So let me open up a new pane here in iTerm. So I'm no longer on the Raspberry Pi here. The Raspberry Pi is the top one. The bottom one is my local machine here. So let me see if I can ping devserver.local. I don't know if this will work immediately because I changed the etc host name after I installed Avahi. So I'm wondering if there is a reboot. Yeah, here's a reload. Avahi daemon, do a reload. Okay, so we'll give this just a second and see if we can ping. If not, we'll keep using the IP address for now, but this would be nice. Let me see if... Okay, we do have, the daemon is running. So that's good. Oh, look, it says ubuntu.local. I might actually restart the whole thing here because I would like to figure this out. So I'm going to do a sudo reboot. This is not my Mac. This is Raspberry Pi. Okay, so I'm going to do a sudo reboot. The Raspberry Pi is rebooting right now. I did change the etc host name. I don't know if a reboot's required after that, or if there's another way to do it, but I'm not going to sit here and figure that out live. So we're going to reboot this and see if it comes up with our new host name after the reboot. So let me do another ping here and see if I can ping devserver.local. I don't know how long this takes to boot up, but probably not that long. Let me try SSHing again using the IP address. Okay, so this is booted now. Let me do another htop and check to see what's running here. So, okay, we do have the Avahi daemon running, devserver.local. So let's see, there we go. Okay, awesome. So what this means is I don't have to memorize this IP address. I don't have to worry about it changing on my local network from DHCP. I can always reference this machine on my network as devserver.local. So I think that we have everything that we need on the Raspberry Pi itself set up. We have Docker, we have Docker Compose, we have the Avahi daemon running, so we have a nice DNS name. Now let's switch gears over into VS Code and use the Raspberry Pi as a remote dev server. So I'm going to just switch spaces here and pull up VS Code. And what you can do is this little connection area down here says open a new remote window. Actually, I'm going to do Command-Shift-P. And we're going to say remote. No, I think you use this down here. Oh, remote SSH. That's what it is. Yeah, remote SSH. So that's what we're going to use. Now, in order to get this option in VS Code, what you will have to do is go to the extensions and search for remote development. And this is a Microsoft supported and maintained extension. Actually, this is an extension pack. So if you install the remote development extension pack, you'll get these 3 extensions here, which will allow you to use VS Code, but you're running everything on a remote machine. So once you have that installed, you should get this little icon in the bottom left in order to connect to another machine. So I'm going to use that, and I'm going to connect the current window to host. And I set up one earlier. This was my Raspberry Pi 2 that I was setting up. That's why I wanted to choose a different DNS name. So I'm going to add a new SSH host. And I will just follow their prompt here. So I'll do SSH Ubuntu at devserver.local. And we will save this in my users config. Host added. So now we'll say, I'll run this through fresh. So we'll go to connect current window to host. We'll connect it to dev server. And we'll see if this works. We'll continue. We'll enter our password. The other thing I could do is set up SSH keys so I don't have to enter my password every time. I won't do that today, but that's probably something I would want to do so I don't have to enter my password every time. Doesn't sound like a huge deal, but especially if you're running on a laptop and you're connecting and disconnecting, then that could be a bigger deal. Okay, this is a good sign. So we have dev server running. So what does this mean? What this means is now in VS Code, it's operating as if it were operating on the Raspberry Pi. So if I go to open a file, I'm not going to see my Mac's file system here. I'm going to instead see the files on the Raspberry Pi. So if I go to open folder here, this is my home directory for the Ubuntu user. This is not my Mac's directory. So that's pretty cool. So what I'm going to do is I'm going to go clone one of my projects. Like I said, this is a, oops, I hit OK to open a file. That's not what I want. You know what? I'm going to close out of that. Let me connect again. Okay, so I have this repository set up for a future project that I want to work on. And it has a Docker Compose setup. And so I'm going to use VS Code to clone that down from GitHub. It's going to clone it onto the Raspberry Pi for me. And then we will try to run Docker Compose and boot it up and see if it's working. So let's go to our repository. So I'm going to use the built-in GitHub VS Code integration to say clone repository, clone from GitHub, and I'm going to choose one of my repos that I'm working on. So I'm going to clone this down. I want to clone it down into, I'm going to make a code directory. Path does not exist. Okay, 1 second. Let me make that path exist. So I'm going to make a code directory here within the home directory of the Ubuntu user. So let's try that again. Oop, clone from URL. Okay, I want to clone it into my code directory. So this is now, do you want to open the clone repository? Yes, I do. Do you want to install the recommended extensions? Show recommendations. Yes, I have this. So this is another thing, is if you're using any extensions, you may have to install them onto the remote server that you're using. So that's what this is saying here. So I had it installed locally, but not on the remote server. By the way, since we're doing all these remote things, let me pull up HTOP again. And you can see that what we have done by connecting to this Raspberry Pi via VS Code is VS Code has, on its own, without us having to really do anything, it has installed some sort of VS Code server that is now running on this Raspberry Pi to support the back and forth between our client, which is my Mac M1. So let me go to my repository here. It looks like this has been pulled down, so that's great. So let me open up Docker Compose here. So what this application is composed of is we have a Postgres server, which is just using the standard Postgres image. I'm on Postgres 11 right now. And then we have a backend service, which is my code that I have in here. It depends on Postgres and it connects to the database. So if all goes according to plan here, what I should be able to do is boot up Docker Compose and have it run on the Raspberry Pi. So I could use the Docker extension within VS Code, but I think I'm just going to pull up a terminal. And you can see here that when I pull up the terminal, this is not my Mac terminal. This is, once again, this is the dev server. This is my Raspberry Pi. And so I'm just going to do a Docker Compose up and see what happens. Okay, failures. Let me increase the file size here. What happened? Okay, permission denied, blah, blah, blah. That's interesting. Okay, I'm going to try to do this in my other SSH window and go to that directory, because this is now cloned on this directory. And let me do a Docker Compose up and see what happens here. Same thing here. So this is still, my phone is blowing up over here. This is still giving me issues. I'm not sure what this error is. Just for kicks, I'm gonna do a sudo docker compose up. I didn't end up doing the recommend. Okay, that's what happened. I didn't end up doing the recommended using virtual env over here. I'm just not as familiar with that because I don't work in Python all the time. So it's probably that what this probably means is that I need to go through this virtual env tutorial and install it this way, because I can see if you are using virtual env, you don't have to use sudo, but if you aren't, you do have to use sudo. Okay, so this is now pulling down. I'm going to Control C out of this actually, because I want to switch back to VS Code. So we're just going to use sudo for now, but this means that I probably need to look into virtual env, not pip, docker compose up. Okay, here we go. So in my previous window, it had downloaded Postgres. Now it is building my app that I just cloned down from GitHub. It's running through the Docker file that I have set up here. And I'll just show you that. So if I pull up my Docker file, I have a fairly basic Docker file here. I'm pulling from the official Node image. I've created a working directory. I'm copying in my yarn and package.json files. I'm doing a yarn install to install the dependencies. This project uses Prisma, so I'm also pulling in the Prisma schema and generating the Prisma client so that I can connect to the database. And then finally, it exposes the ports it needs and runs a command to start the server. So we're looking good so far. It has installed all the dependencies. Now, this is the step, or this is one of the steps that I had failed at on my Raspberry Pi 2, is because the Prisma dependencies weren't compatible with the Raspberry Pi 2, which is older. I think it's ARM v7 I saw, whereas this one is ARM v8, and it's not 64-bit either. So I had a couple of different issues along the way trying to do the same setup on my Raspberry Pi 2, which is why I got the 4. So everything, all the packages built, so that's a great sign. So I'm further than I was on my Raspberry Pi 2. So this is, it'll take a second here to finalize the Docker image, and then we'll see if that boots up with Compose. Let me check my phone real fast. Okay, we're good. Once this boots up with Compose, then the question will be, how do we actually visit the website that this may boot up? What we're going to do is we're going to boot up the Apollo GraphQL playground. And if that loads, we're golden. That means this is a success. What VS Code Remote Development has is, let's see. Okay, we have an error. Let's see here. Unknown system error. Query engine Linux. Okay. This may be another issue specific to this project. And that is, I think there are, since this is an ARM-based processor, I think there are some further steps I would need to take to get Prisma compatible with ARM. I did some Googling on that prior to this. It is pretty extensive. It's doable, but it's extensive. I don't think I'm going to do that in this video. So what I'm going to do instead here is I'm going to modify this slightly just to see if I can boot up Node at all. If I can boot this up at all, then I'll be pretty happy. And I can, after this, go get Prisma compiling and set up with the ARM processor. So I'm going to just actually comment out my Prisma steps in my Docker file, and I'm going to create a new server here. So let me I'm going to do a yarn install express. I'm just going to do oh, I didn't even install yarn yet. That's interesting. How funny. Okay, so I'm going to do if I were on my Mac, I would do a brew install yarn. Yarn. Get started. Install. They recommend NPM installing yarn. Okay. So what I might do then is install Node Ubuntu. What I might do then is apt install Node.js. Okay. Let's just do that here. Okay, so we're going to install Node so that we can get NPM so that we can install yarn. That's what we're doing. NPM install global yarn. Okay, so NPM install global yarn. Okay, we have Node. It's Node version 12. That's old. The current long-term support version of Node as of this recording is 14, and the newest version is 15. So Node 12 is old. So maybe I rushed through this a bit. It might not matter that I'm running Node 12. Okay, it does want me to do sudo apt install npm. Okay, so let me do that. We have a tree of dependencies here. So we're going to install Node and NPM so that we can install yarn, so that I can add just a super simple express server here and boot it up inside a running container inside Docker Compose. And if that's good, then I'm happy. I can go figure out Prisma compilation later. Because I know if you want to custom compile Prisma, that involves getting Rust installed and going from there. So I'm just not going to do that in this video. A little outside of scope. I just want to know that I can run Docker Compose remotely on this Raspberry Pi through VSCode. So apparently NPM has lots of dependencies here. So we're going to do all sorts of things. Overall, though, I've been on air for an hour and 15 minutes now, and so I have to say, that's not so bad for getting this up and running, from literally opening the box, putting it together, booting it up, getting a Ubuntu copied and flashed onto the SD card, getting it set up, installing packages, failing a few times along the way, getting Docker installed, getting Docker Compose, connecting to it. That's not so bad. By the way, if you use GitHub Codespaces, it has a very similar interface to this indicator down here in the bottom left. So I'm curious as to if the VSCode Remote Development is kind of your own version of GitHub Codespaces, but you're using your own server via SSH instead of the official GitHub Codespaces servers. Might be. Not sure. Okay, so still installing all sorts of Node packages. What I'll do in the meantime is, I still need yarn. But what I'll do in the meantime is I'm just going to create a test server file just in plain old JavaScript. And what we'll do is, I'm not even going to mess with imports. We're going to do super, super, super basic. So I will import Express. And then we will make an app. And then we'll do app.get, and we'll get the root, request response, and we'll respond with a send hello Docker. And then an app.listen, we'll call it port 3000, and we'll go. So that's my very simple server where if we do a GET request at the root, we should get text back saying hello Docker. Okay, so NPM has finished installing down below. Let's use that to install Yarn globally. Yarn is probably overkill for this, but we're going to do this anyway. Okay. Let's see if I have yarn. I might have to close the terminal and reopen it. Okay, I'm not gonna mess with yarn then. We're gonna do an npm install express. It says I can get yarn through this command test package, but I'm not sure what that is. I would need to Google that further. So we've installed yarn. Can I just, outside of Docker, can I boot this and run it? Let's see. So let's see if we can do our node test server. It did recognize a port, so I'm going to open this up in the browser. Now, I expect this to succeed, but let's not get excited yet because this isn't running in Docker yet. So if this succeeds, okay, that's excellent. So this is hello Docker. It's forwarding the port. VS Code is forwarding the port from Raspberry Pi locally here, and I can see that as if it were running on my local machine. Now this says hello Docker. We're not actually looking at Docker yet. This is just Node running on the Raspberry Pi. That's cool, but not what we want. What we want is for this to run inside of Docker. So I have modified my Docker development file here. We're going to skip over the Prisma stuff. And what I want the command to be is we're just going to run node test server. And I'm going to expose port 3000. So if this builds and runs in Docker Compose, and we can re-pull up that page, in fact, I'm going to close this, then this will be a success. So let's do a Docker Compose up. No. Oh, I need to do sudo again. Again, I don't want to do sudo, but I think I need to set up the virtual environments for pip, which I skipped over. So after this video, I'm going to go back and set that up. Now this is installing, okay, so I'm going to have a problem here. This is installing, well, that may not be so bad because it copied in package.json, which should have, it does have Express in it. So that should install. Okay, so this is, what this is doing is it's rerunning through my Docker development file that I have here because I made changes to it and it recognized that. So I'm now skipping over the Prisma steps, I'm exposing a different port, and I'm changing the command. So anytime you change something in the Docker development file, it will rerun the first step that changed and all previous steps after that. So it successfully installed all of the NPM dependencies and built the packages. And we did get that far before, but we ended up failing when trying to generate my Prisma client. So that's something I would go figure out after this video, is how to build Prisma on the ARM processor of the Raspberry Pi. But for now, we're not going to do that. We just want to see if we can get an Express server running. So it will take a little bit here to finalize this image. And if that works, then we can, then hopefully it will go right into booting up. It will boot up the database server, as well as just our little test server here in Node. Okay, so we're getting farther. So it's creating the database server, which we're not using the database right now for a test, but it's doing it. And it's creating the backend service, which should be our Node service here for test server. I would bet that, let's see if, I think that, is this the port forwarding tab? I think there was a port forwarding tab. Oh, here's forward to port. Okay, so we'll see if, oh, you know what? Since I changed that port, I may have to go make a Docker Compose configuration change, because I have this set to, I have port mapping here for the app I've been working on set up to 5100 and 9229. I'm going to add in port 3000 here. And you know what I need to do is I don't have any console statements to say that I booted up the server. So we're going to shut this down. We've gotten farther. I'm going to also expose, I'm going to expose port 3000 here. And I'm going to, in here, there's a callback to listen. Host name. Oh, let me go ahead and do 0.0 0.0.0. You have to do that for Docker most of the time. And I'm going to do a callback to say node server booted. So we've done all of those things. I have a syntax error, which I didn't spot. That's a good sign, though. Okay, so the node server booted. I didn't get the automatic port forwarding prompt in VS Code, which leaves me a little wary. But let's see. I've gone ahead and manually put it in here. Let's see. Hey, there it is. Okay, now that's the same one that showed up earlier. So I'm gonna go ahead and change this to like, hello Docker, compose. So I'm gonna change that and we're gonna make sure this actually says what we want. Okay, let me open that again. And there's hello Docker compose. Awesome. Okay, so I'm so happy. So what this means is I have my Apple M1 MacBook Pro, which is not yet compatible with Docker. The Docker folks are working on it. I hope that Apple's helping them. What the backstory is on that, by the way, is at WWDC when Apple released the dev machines, so that companies could start getting all their apps compatible with the M1. What I read about it is that the dev machines didn't yet have the virtualization tech in those M1 chips. It wasn't released yet. And so Docker really hasn't been able to work on it all along. That's kind of my understanding. So as the public has been getting these M1 machines, that's kind of where we've started. That's why it seems a little bit behind. But what this means is I have a brand new Apple M1 machine. It's not compatible with Docker yet. However, I can use VS Code and the remote development extensions to connect remotely to this Raspberry Pi. This Raspberry Pi here, and develop like normal. So as long as I have this Pi with me, which thanks to the pandemic, I'm pretty much always in the same place anyway. As long as I have this Pi with me, then it will be very easy to continue my development using Docker, just as if I were before, because I can do everything here in VS Code, pulling down my repositories, getting Docker Compose set up. I can completely customize this machine to however I need it to be and continue on development. So that's pretty cool. Another side benefit of this, even if I didn't have an M1 machine, or even when Docker for Mac becomes compatible with the M1, what this means is that the horsepower that it's taking to run my development servers has now been offloaded to the Raspberry Pi. And so this may be something I continue even after Docker for Mac becomes available and compatible, is to run this on the Raspberry Pi just simply to offload the resources from my main machine here. So that would be a really nice benefit of this as well. But to sum up, what we've done is I have the Apple M1 machine. I purchased and just arrived today this Raspberry Pi 4. I got the 8 gigabyte one, but it comes in 2, 4, and 8 gigabytes. This CanaKit that I bought off Amazon, I think it was $130. Comes with everything you need. No Ethernet cable, but it comes with everything else that you need. We installed Ubuntu on it using the Raspberry Pi Imager utility that you can download from the Raspberry Pi website. We installed Ubuntu 20 64-bit version. Then we got our dependencies of Docker and Docker Compose installed with a little bit of Python along the way. And I used the Avahi daemon to be able to reference this machine with a friendly DNS name on my local network instead of having to mess with the IP address changing on me. And now with VS Code, I have the remote development extension installed where I was able to connect with this Raspberry Pi server and pull in my repos and run Docker Compose here in VS Code. So I think that's a success. I'm very happy with this. I think this will be awesome for developing. So what will I do from here? So what I'll do from here is I want to figure out how to run Docker Compose without using sudo each time. So I think that has to do with setting up a virtual env for pip. So I'm going to go research that a bit more. Next up, the projects that I do use in Docker use Prisma because I'm a big Prisma fan for connecting with databases in Node and JavaScript and TypeScript. And I think that there is some custom compilation that I'm going to have to do with that. I started doing that on my Raspberry Pi 2, so I know that that's available, but I ended up failing because it wasn't compatible with this. But I'll probably have to go install Rust and get Prisma compiling. And also figure out Yarn, why Yarn wasn't working. But I have Docker Compose booted, Node test servers running, port forwarding's working, and I was able to pull up this Hello Docker Compose. So pretty happy with that. Not too bad. An hour and 32 minutes, hour and a half. Well, thanks for tuning in. I hope you found this useful or entertaining or fun. I'm pretty excited about getting this set up. I'm even more excited that Docker development isn't going to hold me back from using my new M1 machine. And we'll go from here. If you liked this video, let me know. Leave a comment, leave me a like if you like. And hope you have a great day, and I'll see you next time.